Hey everyone, Mike from vSwitch0 here. So before I dive into this repair video, I just wanted to share an exciting announcement with everyone. My channel has just hit a major milestone and passed the 1,000 subscriber mark, something I never imagined I'd be able to achieve when I first started this small channel, so I'm really just thrilled. And as you may have noticed, I'm continuing to make improvements to the way I'm doing these videos, and I'll try to share some more channel updates with you in the coming weeks and months. But I just really wanted to sincerely thank all of you. I do try to read and respond to every comment I get, and I'm really just overwhelmed by all the kind words and encouragement I get on a regular basis. It really helps to keep me motivated, and it does mean a lot. So again, thank you all very much, and I really look forward to continuing on this journey with everyone. So in my hands here I have somewhat of a unicorn in the retro PC world. This is 3dfx's last mass-produced, commercially available card, the Voodoo 5500. And 3dfx's business failed shortly after its release, which is a long story for another day, I think. But as you've probably noticed, this card is highly sought after these days, and it demands pretty ridiculous prices on eBay, that's for sure. I never actually had a 5500 back in the day, but I always thought it was so impressive with its dual chip setup. And of course, it was made by 3dfx, a company and brand that I really loved back then. A few months ago, I was able to find one for a half-decent price on eBay, and I decided to jump on it. Now, Voodoo 5s aren't really known for their reliability, so I did make sure it was sold in quote-unquote working condition, and the seller was willing to accept returns. And sure enough, it was indeed broken. It sort of half-worked, which I'll talk more about later, but I worked it out with the seller, and rather than taking the card back, he was willing to give me a partial refund, a rather generous one actually. So I used the refunded money to send the card office to the famous Oscar in Spain, who is arguably the world's leader in VSA-based card repairs and enhancements. Oscar quickly fixed the problem, which turned out to be bad memory on the card, and he even overhauled the cooling system for me. Looks really amazing, and I can't wait to get it. It should actually be en route to me from Spain right now as I speak. Wait a second, didn't I just say the card's in Spain? Yeah, this is actually a totally different Voodoo 5. Shortly after Oscar fixed my first card, I came across this one from a Canadian seller. The price was actually excellent, but as expected, it was sold as is, untested. I tried my best to get the seller to tell me anything about its history, but all he'd say is he couldn't test it because of an incompatible system. Not really sure I believe that. I sort of just translated that as, yes, it's broken, but I get it. It's easier to sell an untested part than a broken one. But hey, for that price, it was way cheaper than even broken cards were going for, so there was really no way that it would be working. But that's okay. The pictures the seller provided, I mean, they weren't really the clearest, but I couldn't see any signs of physical damage, which was at least a little bit encouraging. But really, the price was too good to pass up. If I could get the card working, it would absolutely be worth it. And worst case scenario, if I can't fix it, I could always send another one to Oscar if I had to. So when I first got the card, the first thing I noticed, it was absolutely covered in flux residue, almost every inch of the PCB on the front and the back. Definitely a sign of a repair attempt. And that's not all. I also noticed that there was a capacitor that had been replaced here. It probably broke off at some point. Someone soldered it back on, which was not really the cleanest job, but definitely looks okay. I also noticed that there was an attempt to reflow some solder on at least 2 memory chips on the card, and whoever did this left 2 pretty sizable solder bridges shorting out some pins there. As it is right now, there's really no way the card would be working properly, that's for sure. These would definitely have to be dealt with. And last but not least, I see 2 surface mount capacitors and a surface mount resistor that are actually missing from the back of the card near the VRM components. And because these appear to be part of the power delivery system, their absence could be pretty serious, so I'll need to find values for these and get them replaced as well. So before I begin with the repairs, I just wanted to take a moment to mention that I'm definitely not an electronics repair or soldering expert by any stretch of the imagination. I think I have come a long way in the last 6 or 12 months or so as I've gotten more experience, but I am still learning. I do try to avoid the quote-unquote wrong way of doing things as much as possible, but there's often multiple right ways, and I doubt very much that I'm doing things in the easiest or most efficient way at times. So for those soldering experts watching this and probably cringing at certain points, I apologize in advance. But for anyone who's new to soldering or trying to do a repair like this, please do proceed at your own risk. There's a lot that can go wrong when you do this type of work, and I can't emphasize enough how important it is to get some practice on scrap boards before working on gear that you actually care about. And of course, when soldering, you do deal with lead, and especially on older gear, so flux fumes, other chemicals. You definitely want to make sure you have good ventilation, and as always, be sure to read the safety warnings on products that you use. Alright, so let's get started by fixing the problems that I can see here. As it is right now, I don't really even want to try and power up my system with this card in it. It's very unlikely to work, and I don't want to risk making anything worse either, so I'm going to use my digital microscope for a lot of what I'm doing here today. You can use a magnifying glass, but at any rate, you're definitely going to need some visual assistance with this kind of fine pitch work, that's for sure. Alright, so after getting the card cleaned up as best I could, first order of business, let's take care of these solder bridges. So you can see here that these two pins are clearly shorted out with a little blob of solder. I'm just going to take some wick here and I'm going to just try to remove a little bit of it. I don't want to remove too much because I don't want to suck up the wick from the other pins nearby. But yeah, you can still see there's a little bridge there, but if I just heat up these pins, it should reflow the solder onto them and clear up that bridge. And yep, that looks good. Next we'll move on to the other one here. You can see it's the very last two pins. There's a sizable blob there. I'm going to do the same thing again, just with a little bit of wick to remove a little bit of the solder from that blob, and then just reflow it onto the pins as well. And there it goes. Looks like it's now fixed. Just going to reflow this a little better and should be good. So with those bridges fixed, I'm just going to use some isopropyl alcohol to clean up the flux residue that I left behind here. And then I'll spend a little bit of time just inspecting it real close, make sure I didn't miss any other bridges, but I think that should be all of them. So next I'm going to deal with the missing surface mount components. There's two capacitors, C501 and 502, and one resistor R504 that are clearly broken off here. They're located on the back side of the card at the top left-hand corner, just opposite of the power regulation circuitry. And because these could be important for stable power delivery, definitely want to get them replaced before trying to power the card up for the first time. I had no idea what values to use for these components, so I did some digging online and I eventually found a very helpful component map for the Voodoo 5. It was on a German forum called Voodoo Alert. It's not a complete map, but thankfully the three components I needed were all listed there, and I'll include a link to it in the description if anyone's interested in seeing it. So R504 is a simple 10 ohm 0603 type resistor. C501 is a 100 nanofarad 16 volt part, and C502 is a much higher capacitance part, 3.3 microfarads at 16 volts. Thankfully, DigiKey had all the parts I needed in stock. I got Panasonic branded parts with the exception of the 3.3 microfarad capacitor. TDK seemed to be the only company that made that one. So before I can install the new components here, I'm going to need to get these pads cleaned up. I'm just going to put a little bit of flux paste on each of the pads, and then I'm just going to heat them up with my iron in order to remove the little bits of capacitor and resistor that are left behind. You can see when I heat it up here, the little piece just slides right off and sort of attaches to my iron, and I can get them off that way. I'm going to do that to all of them here, and then I'm going to use some wick just to clean up the old solder that's still left behind on the pads. And then I'll get that all cleaned up with some isopropyl alcohol, get rid of all the flux residue that I've left behind there. And once it dries, hopefully it's going to look good as new and be ready for the new components. Yep, looks nice and clean. I'm happy with that, and I think it's ready to go. So I'm just going to add some additional flux paste to each of the pads here. And I'm going to pin the component in place with my tweezers here. And I'll tell you, these things are really small, so it's kind of hard to get them held in place. They do move around quite easily. But once I've got it held down here, I'm just going to touch the pad very briefly with my iron. I had a little bit of solder preloaded on it, and really that's enough. The blob that it put down is maybe a little bigger than it should be, but it works, and hey, it's not going to look as clean as something done by a machine with the original components, but I'm pretty happy with that. It looks good. Just going to repeat the same process here with R504. Really no difference doing a surface mount resistor and a capacitor, really the same. And there we go. Just do the other side too. And the final capacitor. Just do one side to tack it down. And then we'll get the other side as well. And there we go. All done. I think that looks pretty good. A little more solder than I was hoping to put on there, but again, we're looking at it at a pretty microscopic level here. Once you sort of look at it with the naked eye, you can't really tell, and it sort of looks like all the other ones. So I haven't done too many of these, but I'm pretty happy with how that turned out. All right, so now for the moment of truth. Now that I've got all of those obvious sort of damage type problems sorted out on the card, I can feel comfortable enough now to plug it into my system and see what we actually get. This is the very first time I'm powering this thing up, so I honestly have no idea if it works at all. As I mentioned before, the seller really wouldn't tell me anything about the card, so this is going to be a little bit of a nerve-wracking experience powering it up for the first time. But let's see what happens. And hey, look at that. We see the Voodoo 5 5500 BIOS show up. That's very encouraging. And we at least have 2D VGA output. Doesn't look artifacted or garbled or anything like that. So encouraging so far. So this is my Athlon 700 system, which is running Windows 2000 Professional. I was using this system to test my other Voodoo 5 card, so I've already got the drivers installed and it should be all ready to go. It's looking good so far, and it certainly looks like the card was detected. And now it's going to be the moment of truth. Will it run a glide game? So I'm going to try the gold standard in my books, which is GL Quake. Oh, that doesn't look good. Nothing but a black screen with a repeating pattern of blue artifacting. And yeah, it looks like the system froze up pretty solid here too. So I'm not 100% sure yet, but this type of problem is usually due to bad memory. So, but we're going to try something else here first. So the Voodoo 5 has two 3dfx VSA 100 chips on it. One is a primary and the other is a secondary. So the primary chip, which is the one that's closest to the bracket, it handles all of the normal 2D duties in addition to 3D acceleration. The secondary chip is really only used when a glide or direct 3D application is launched. And it's basically using 3dfx's SLI technology, but on a single PCB instead of across two cards. So each VSA has its own dedicated 32 megabytes of memory. So that's 4 chips per VSA, 2 on the front, 2 on the back. And we know that the primary chip in its memory is working to some degree because 2D functionality is fine. And I'm not seeing any artifacting or anything to hint at, a memory problem on that half of the card. Conveniently, 3dfx's drivers actually allow you to disable the secondary VSA 100 chip, basically turning off SLI for compatibility purposes. This basically just turns the card into a Voodoo 4 more or less. So this is really handy for us for our troubleshooting though, because if the card is stable with the secondary VSA disabled, then we can essentially rule out one VSA chip and 4 out of the 8 memory chips as well. It really lets us focus in on what the problem could be. So let's do that and see what happens. So let's see what happens in single VSA mode. Oh, look at that. It's running. So that's great that you can do that. So we've essentially narrowed down the problem to one half of the card now. Obviously, I'm not sure if this thing's totally stable, but I'm going to run through a time demo and I'll let it loop for a little bit. But the funny thing is, this is literally the exact same problem and behavior that I had with the card that I sent to Oscar to repair. And after speaking with him for a little bit, I mean, I've seen that the memory on these cards is sort of notorious for going bad. I'm not sure if it's just the Hyundai or Hynix chips that are sort of dying over time or what the case may be. But if you just look at his tweet history where he shares some of his repair experience, so many of these cards just have bad memory. So I went and I bought these Alliance chips here. It was kind of hard to find the exact replacements, but these are actually brand new, dated 2021. And they're the same specifications, so I'm going to give it a shot and we're going to try to replace these chips one by one on the secondary VSA until we get to the bad one, and we'll see if we can get this thing going again. So because I have no idea which chip is bad, I have about a 1 in 4 chance of finding the right one. I mean, it could in theory be more than one bad chip, but anyways, I'm going to just replace them one by one until the problem goes away. I'm going to start at the rear of the card because they're a bit easier to get to. There aren't as many components in the way and stuff like that. Plus, these are the ones the previous owner was trying to reflow, so it seems as good a place as any to start. To remove the chips, I'm going to use my hot air rework station, but first I'm just preparing the card here. I put some Kapton tape on nearby passes just to shield them a bit and prevent them from blowing off the board. I'm also applying a very generous amount of flux paste on all the pins to help the solder flow. I've done chip removal a few times on some scrap boards for practice, but this is the first time I'm doing it on hardware I actually care about, so wish me luck. It's always a little bit nerve-wracking doing this because it's very easy to lift a pad or damage something if you're not careful. I'm applying almost no pressure at all here, and very slowly I can feel the chip just let go and it comes up without any effort at all. It's smoking quite a bit here, but I didn't cook it. It's just a lot of flux that ran underneath and it got burned off when I pulled it up. So yeah, looks pretty good. Came off very cleanly, and that's one step down. So before I can put the new chip on, I'm going to have to clean up these pads really well. I'm going to use solder wick here. I'm just dabbing it very carefully. And again, these pads are very small and delicate, so you got to be very careful. I would definitely advise against trying to drag the wick across. But after doing that, it looks really clean. I'm quite happy with how that turned out. I'm just taking a quick look at it under the microscope to make sure I don't have any blobs or anything on any of the pads. Just want to make sure they're nice and flat and reasonably clean. To apply the new chip, I'm going to use this Amtech Tachyflux. It's the first time I've used it, but Tachyflux is nice because it gives a little bit of hold while you're trying to place the chip in just the right position. The normal paste stuff, it moves around a little bit more, so I'm going to give this a try here and see how it goes. So getting the new chip lined up can take some time and it can be quite frustrating, but the Tachyflux does help. Once you've got it in place, you can just press down on the chip a little bit and it will hold it in place well enough for you to get it tacked down. And to sort of secure it so that you can get the other pins, all you really need to do is solder the last pin on two opposing corners. Once those are done, you don't really have to worry about it moving around anymore and you can get to the other ones. And here my lack of soldering experience kind of shows. I've tried various ways of doing drag soldering, where you drag a loaded iron across the pins. But every time I've tried to do that, I tend to just make a big mess and I apply way too much and then I have to clean it up with wick. So I know there are better ways to do this, but I prefer to just dab away at one or two pins at a time and slowly go across them all. I feel more in control this way and it does work for me, so I'm going to stick with this method for now until I can get more experience doing other ways. And you'll notice that there are some bridges being created as I do this, but when you apply only a small amount, it's not difficult to get it to flow across adjacent pins. If there is a bit too much that you can't get flowed away, you can just use some wick like I'm doing here, and that does seem to work. So after patiently doing all 86 pins and then eventually getting it cleaned up, I think the end result looks pretty good. Not as clean as the factory, obviously, but for somebody pretty new to this, I definitely can't complain. Now, the big question, of course, did it fix it? Sadly, no. But the strange thing is that the artifacting actually changed. Unfortunately, I misplaced the video recording of my attempt after changing the first chip, but if I had to describe it, I would say it's a pattern of colorful squares with bits of the Windows background visible through the artifacting. This was both encouraging and discouraging. It meant that I changed something. I either improved things and there's just another bad chip on the secondary VSA, or it could also mean that the chip I just installed was bad or incompatible. But hey, it was the first one I tried, so I'll try and be positive, and we'll just assume there's another bad chip and I'm going to keep going. So after gaining some very useful experience doing the first chip, I went ahead and did the other one on the back of the card. This time there was no change at all. I still got the colorful artifacting just like before. Discouraging, but I was determined to keep going, and I did a chip on the front side of the card as well. But sadly, again, there was no change at all with the artifacting. It looked identical. One chip I could understand, two, yeah, quite possible, but three, now the odds were definitely in my favor. But that's when I decided to go back and really scrutinize my work on the other chips, especially the first chip. It really just kept bothering me that the artifacting changed but didn't go away. I checked literally every solder joint. I went so far as to check every adjacent pin with a multimeter to ensure there weren't any shorts. And sure enough, there was a tiny, almost invisible solder bridge up near the top of the pins that were shorting out there. So after correcting that bridge, it's time for the moment of truth. I'm going to switch it back to dual VSA mode here, and we're going to see if GLQuake works. I must say I'm quite nervous to give this a try, but I'm feeling kind of optimistic, so let's see what happens here. Yes, it works. That was it. So I'm embarrassed to say that it was probably the first chip the whole time, so I replaced two that I more than likely didn't need to change out. So after all that hard work, my joy was pretty short-lived, unfortunately. After about 10 minutes of looping GLQuake, the system just froze, and when I rebooted, I got no display output at all. Nothing I did could seem to get it out of this state, but after leaving the card to cool down for a while, eventually it started working again. But it was never very stable for some reason. I did check all the memory yet again, but everything looked fine, and really, the secondary VSA in its memory should have nothing to do with the problem that's preventing VGA output at boot up. Sometimes it would work for a few minutes, other times it would crash immediately and I just get horizontal white lines like this. But man, the only thing worse than a broken card is one that only intermittently works. Then by chance, I had GLQuake running, and I touched the Molex cable, and at that very moment, the system crashed with artifacting. It was a bit of an aha moment. I definitely needed to take a closer look at that part of the card. So after inspecting everything in that area, I turned my attention to the LTC 1929 CG chip. The LTC 1929 is a step-down switching regulator that works with some other components on the card to provide the 2.9 volts or so required by the VSA 100 chips. Needless to say, this is a very critical component for power delivery. And interestingly, Oscar actually replaces this chip along with doing a full recap of the card as part of his tune-up service. But because it's a service mount component, it can suffer from bad solder joints, and sure enough, I found no fewer than 3 of the pins with flaky contacts. With both VSAs in operation, the power draw and heat generated is obviously a lot higher, and the card heats and cools, and these flaky contacts can become very problematic and cause instability. But thankfully it's a very easy fix. All I'll need to do is just add some flux and a bit of fresh solder to give the pins a reflow. I decided to do the entire chip instead of just the problematic joints just in case. And because this is a power chip, unlike memory, it won't be very forgiving of solder bridges, so I was very careful not to leave any pins shorted out. So after double checking all of the joints to make sure there were no bridges and that everything was nice and secure, it was time to test the card again and see if things are better. And yes, indeed, all traces of instability and flakiness were gone. The bad joints on the LTC 1929 were definitely the problem. I was able to loop GLQuake for over an hour with both VSAs enabled, and I was able to play an extended session of Quake 3. And just to be sure, I even left 3D Mark 2001 looping. But wow, the list of problems this card had was quite long. Broken off surface mount components, solder bridges from the previous owner, a bad SDRAM chip, and last but not least, flaky contacts on the LTC 1929. But in the end, it was totally worth it. This was a really great learning experience for me, and there really is nothing quite like the satisfaction of knowing that you were able to do it yourself. So what's next? I do have some plans for this card. At some point, I'll probably be doing a quote-unquote ultimate year 2000 gaming build. But before then, I may take some time and give this card a full recap as well. I think cards like this are definitely special and deserve proactive maintenance like that. So that's it for today. Thanks so much for watching, and as always, if you'd like to see more retro content like this, please be sure to like and subscribe. It really does help smaller channels like mine get more exposure on YouTube. Thanks again.